Hello everyone, I'm Aditya and today we are going to discuss the Physics 2211 Lab 4, which is Oscillations. The table of content includes introduction and purpose, followed by formulas, followed by the analysis of mass motion, computational model, sources of error, discussions, and conclusion. The purpose of the experiment was to compare the observed model with the predicted model of mass attached to a spring. Secondly, we had to plot the energy changes after the computation in the model, which included kinetic energy, gravitational potential energy, spring potential energy, and finally the changes in the total energy. The key ideas here are Newton's second law and the energy principle. The system in this experiment is the Earth, spring, and the mass, whereas the surrounding is none. The key formulas used for the experiments are Fg is equal to minus mg j hat, g is equal to g me by r square, Newton's second law, which is F is equal to ma, velocity update formula, and position update formula. The main formulas used for the experiments are energy principle, which states that the change in the energy of the system is equal to the work done plus Q, which is the change in the temperature. Finally, after that, delta K, which is the kinetic energy, delta Uj, which is the gravitational potential energy, and delta Us, which is the gravitational spring energy formula are shown below. Now let us look at the tracker analysis. A tracker model was used to analyze the motion in both X and Y axis, and then the Excel file was converted into CSC file as shown below. The initial conditions for the experiments are the ball mass was 0.402 grams, the initial position was minus 0.109 and minus 0.062, and the initial velocity is 000. The spring constant was taken to be 6.83, whereas the relaxant was taken to be 0.123. The kinetic energy, gravitational potential energy, as well as the spring energy was calculated. Finally, the total energy was calculated by adding all of the three together. The predicted model is shown below. This is a very important slide. As you can see, we first calculated the gravitational force, then we calculated the spring force on the mass by the spring, then we calculated the net force by adding the spring force plus the gravitational force. Then we applied the Newton's second law, which is the velocity update formula, and the position update formula to find the position and the velocity. Finally, we updated the spring, and then we found the change in kinetic energy, change in potential gravitational energy, and change in spring energy. Finally, all of them were added together to find the change in total energy. The results are as shown below. The sources of error could include the forces from the surroundings like drag may lead to an error. Secondly, it could be inconsistent approximation as the experiment was performed manually, and then it can have manual error. Using the data, here a question asks about estimating the period of oscillations in both x and y axis. So in the x-axis, the total time taken for 3 cycles was 4.938 seconds, and hence the time period was 1.646 seconds, which was found by dividing the total time taken by 3. The y component, the time period is 1.575 seconds. Conclusion. For a model, is the energy principle satisfied? Yes, we can say that the energy principle is satisfied as the change in total energy is always zero. The kinetic energy and the potential energy are equal and opposite, and hence the total energy comes out to be zero. It could also be justified by saying that no work has been done, and hence the total energy is zero. Thank you.